Welcome to the Deep Dive. We love to go deep on complex topics. Today, it's all about AI and how it's tackling some seriously hardcore math problems. We got some research on this recently, and wow, it gets intense.
Yeah, cutting edge is putting it lightly.
But don't worry, we're going to break it down for you. No PhD in math needed here, just a healthy dose of curiosity. So buckle up, because we're diving into a world where AI isn't just writing code or playing games, but pushing the very limits of what we understand about mathematics.
Exactly. It's about pushing the boundaries of human knowledge.
This research dives headfirst into a problem that's been stumping mathematicians for decades, something called the Andrew Curtis Conjecture. Ever heard of it?
It's a tough one, even for mathematicians. It basically asks if you can take any balanced presentation of this thing called a trivial group, which is a group with just one element, and transform it into a standard form using a specific set of moves. Sounds simple enough, right?
Right.
But some of these presentations are incredibly resistant to those transformations.
It's like a puzzle where the pieces keep changing shape.
Perfect analogy. The moves are like rearranging those puzzle pieces in specific ways, trying to get them into a certain configuration. But the more you rearrange, the more complex the puzzle can become.
And that's where AI steps in to help us solve this crazy complex puzzle.
Exactly. Think of proving this conjecture like a massive search problem. You're looking for the perfect sequence of moves. But the number of possible sequences just explodes. It's like searching for one specific grain of sand on an entire beach. Traditional AI approaches, like brute force searching, just can't handle that kind of complexity.
So it's not just about throwing more computing power at it. You need a smarter way to search.
Exactly. And here's where it gets really interesting. Researchers have been testing out this type of AI called reinforcement learning. You might have heard of it with things like AlphaGo, the AI that mastered Go.
Oh yeah, I remember that. Beat some of the best Go players in the world.
Yep, that's the one. So in reinforcement learning, the AI learns through trial and error, tries different moves, and gets feedback, like rewards or penalties based on how well it's doing. Researchers applied this technique using a specific algorithm called proximal policy optimization, or PPO, to a set of over 1,190 presentations from what's called the Miller-Jupp series. These Miller-Jupp presentations are known to be particularly challenging, like the expert-level puzzles of the Andrew Curtis world.
So they threw the AI right into the deep end, huh? How'd it do?
Well, it managed to stay afloat, even made some impressive progress. It didn't outperform seasoned mathematicians using their own techniques, but it solved more of these problems than a basic search algorithm could.
So showing some real potential then.
Oh, definitely. It even managed to solve two presentations that had stumped mathematicians for years.
Wow. Seriously.
Yeah. Specifically, presentations X, Y, X1, 4, XY4, X1, Fa 1Y, X1, 4, X1, Phi, XY, XY1, X1Y, XY1, 21Y, XY1Y, XY1, Y1, Y, XY1, Phi, XY1, Y, XY1. The first one is really similar to one from the Akbulut-Kirby series, which are notoriously difficult. So the fact that AI cracked them is a big deal.
That's what's so exciting. It's not just blindly pushing through calculations. It's navigating this complex mathematical landscape and finding new paths that we hadn't even considered before.
But you mentioned earlier that it's not perfect, that there are still challenges for the AI, right?
Absolutely.
One of the biggest hurdles is something called the horizon problem. Think of it like trying to solve a maze, but you can only see one step ahead. You might end up wandering around in circles forever.
Sounds frustrating.
It is, and it's the same for the AI. When the solution needs hundreds or thousands of steps, it's hard for it to know which early moves are going to lead to success. It gets lost in the short term and can't really plan for the long game.
So even though it can make those impressive moves, it lacks the strategic vision to see the bigger picture.
Exactly. That's one of the key areas researchers are working on, how to give the AI a better sense of long-term planning and strategy.
So it's not just about making the AI smarter, it's about making it a better strategist. That's fascinating.
It is, and this is where the research takes another interesting turn. They started looking at ways to actually measure the inherent difficulty of these math problems. They found a way to quantify how much longer a presentation actually gets during the transformation process.
So you can tell how much a math problem is going to fight back as you try to solve it.
You got it. It's called the O increase. It's giving us a better understanding of why some presentations are so resistant to being solved. They're like those 1,000-piece puzzles that just never seem to fit together, no matter how hard you try.
And knowing this hardness factor is helping researchers build even better AI systems.
Right. They're analyzing these really difficult cases, figuring out what makes them so tricky, and then using that knowledge to develop new AI strategies and algorithms.
So the AI is learning from the toughest problems.
Exactly. And that brings us to one of the coolest parts of this research, the concept of adaptive AI.
Adaptive AI. Now, this sounds interesting.
It's all about creating AI that can learn how to learn. Imagine an AI that can not only solve super tough math problems, but also identify patterns in those problems and actually adjust its approach accordingly.
So it's not just about solving one problem at a time. It's about understanding the underlying principles and applying them to new challenges.
Exactly. It's like teaching the AI to think like a mathematician, to develop that intuition and strategy that can be used across a wide range of problems.
That's incredible. So this research isn't just about building a better math machine. It's about pushing the boundaries of AI itself, creating systems that can actually learn and adapt.
Exactly. It's a glimpse into a future where AI isn't just a tool, but a partner in exploration and discovery.
Okay, my brain is officially buzzing with all of this.
Mine too. And believe me, we've only just scratched the surface.
Can't wait to dig deeper. We're back, and our brains are still buzzing from that last segment. We're talking AI and mathematics, folks, a combo that's sparking some serious innovation.
No doubt about it. It's changing how we approach math at a fundamental level.
Before the break, we were talking about adaptive AI, how it's learning to solve these incredibly tough math problems and even adjust its approach based on what it encounters.
Right. It's not just about finding a solution to a single problem. It's about developing strategies that can be applied in a whole range of problems.
It's like the AI is developing its own mathematical intuition.
You could say that it's starting to see patterns and make connections that we might miss. That's what makes this research so exciting. It's pushing the boundaries of what we thought possible in math.
It's like the AI is opening up these new pathways in mathematics that we didn't even know existed.
Exactly. And that leads us to another fascinating aspect of this research, the use of language modeling to understand the structure of mathematical presentations.
Okay, now this is where my brain starts to bend a little. Language modeling for math.
I know, it sounds strange at first, but it's showing real promise. Think of it this way. Researchers are treating these mathematical presentations as if they were sentences in a language. They're using techniques from natural language processing to analyze the patterns and relationships between different elements.
So they're looking for the grammar of math.
Precisely. And what's fascinating is that the AI can start to predict which presentations are likely to be solvable and which ones might be unsolvable.
Wait, so the AI can tell whether a problem is solvable just by looking at its structure?
Yep, even without actually trying to solve it. It's like being able to tell if a sentence is grammatically correct just by looking at the order of the words. You don't even need to know what the words mean.
That's pretty amazing. So how does this mathematical grammar actually help us solve problems?
Well, it helps us focus our efforts. Instead of mathematicians spending time on presentations that might be impossible to solve, they can use these insights to prioritize the ones that are more likely to have solutions. It's all about working smarter, not harder.
So it's like having a roadmap for mathematical research.
Exactly, and this is just the beginning. There's a ton of excitement about the potential of language modeling to reveal even deeper insights into the structure of mathematics. Imagine being able to classify different types of math problems based on their inherent grammatical structure, or even generating new mathematical conjectures by manipulating the language of math.
That's mind-blowing. It's like we're on the verge of a whole new era of mathematical exploration where AI is our partner in discovery.
It's a really exciting prospect.
It really is. But let's take a step back for a second and think about the bigger picture. If AI can solve problems beyond our understanding, what does that mean for the future of mathematical discovery? Are we about to uncover secrets that have been hidden for centuries?
That's a question that has mathematicians and computer scientists buzzing, and it's something we'll explore in more detail after the break.
Welcome back to the Deep Dive. We've been on this incredible journey exploring how AI is pushing the boundaries of mathematics.
And we've landed on some pretty thought-provoking questions along the way.
Before the break, we were pondering the potential of AI to crack mathematical mysteries that are beyond human grasp.
It really makes you wonder about the nature of understanding itself, doesn't it? If an AI can solve a problem we can't even wrap our heads around, does it truly understand the solution? Or is it just crunching numbers and symbols without any real comprehension?
It's like if a computer can beat a chess grandmaster, does it really get the strategy behind the game?
Exactly. That's the challenge we face when we try to gauge AI's understanding in a field as abstract as mathematics.
So how do we even begin to figure that out? How do we evaluate AI's comprehension?
Well, one approach is to focus on explainability. Can we design AI systems that not only give us solutions, but also give us proofs or explanations that we can follow, even if the concepts themselves are initially over our heads? If an AI can explain its reasoning in a way that makes sense to us, it would be stronger evidence of real understanding.
So it's not just about getting the right answer, it's about showing the steps you took to get there.
Precisely. And that's a hot topic in AI research right now. Scientists are working hard to develop AI systems that can generate proofs that are both logically sound and understandable to us humans.
That's amazing. It'd be like having an AI math tutor that can walk you through even the toughest concepts step by step until it all clicks.
Absolutely. And think of the potential for education. Students could have access to AI systems that tailor explanations to their learning style, making even the most difficult math concepts accessible and engaging.
It'd be like having a personal math coach available anytime, anywhere. But let's not get too ahead of ourselves. We're still in the early days of this research. What are some of the hurdles scientists are facing?
One of the biggest challenges is building AI systems that can generalize their knowledge to brand new problems. It's one thing for an AI to solve problems it's been trained on, but it's a whole other ballgame to apply that knowledge to a fresh problem it's never seen before.
So it's about more than just memorizing solutions. It's about grasping those fundamental principles and being able to use them creatively.
Exactly. And that requires a level of abstract thinking and flexibility that we haven't quite cracked in current AI systems. Plus, we need to make sure these AI systems are reliable and trustworthy. The solutions they give us have to be right, and we have to be sure they haven't been skewed by any biases in the data they were trained on.
That's a critical point. We don't want AI amplifying existing biases or steering us in the wrong direction.
Absolutely. Transparency and accountability are crucial. We need to be able to look under the hood and see how these systems make decisions, and we need to be able to spot and fix any potential biases.
So it's not just about building powerful AI, it's about building it responsibly.
Exactly, and that requires a team effort. Computer scientists, mathematicians, ethicists, and policymakers all need to work together to ensure that AI is used ethically and effectively to move our understanding of math and the world forward.
It's a good reminder that even when we're exploring the cutting edge of tech, we can't lose sight of our ethical compass.
Definitely, but if we're careful and work together, the potential benefits of AI in math are just staggering. Imagine breakthroughs in fields like physics, cryptography, economics, all thanks to AI's assistance.
It's an exciting time to be witnessing these two powerful fields, AI and math, come together.
It really is, and who knows what incredible discoveries lie ahead. One thing's for sure, the future of math is deeply connected to the future of AI.
That's a great point to wrap things up on. We've covered so much ground today, from the nitty-gritty of how AI is tackling tough math problems to the big picture questions about AI's understanding and the ethics of its use. It's been a mind-expanding deep dive, and I bet our listeners are eager to learn more.
I hope so. This field is changing fast, so there's always something new to explore.
Well, we'll definitely keep you updated on all the latest developments. Thanks for joining us on the deep dive. Until next time, stay curious. 8PR.